This video is about applying a real-world problem to the standard normal curve. So today in class we started by just finding some basic proportions with z-scores. So take a moment and do these. I'll show you the first one, and then maybe you can pause it and try these out on your own. So we're using normal CDF on the calculator, and by the way, let me show you where to find that on the calculator. You go to your calculate screen, press menu, stats, distributions, and normal CDF. Let me do that one more time. Menu, stats, distributions, normal CDF. And so I'm going to write down some lower and upper bound numbers, and then you'll be good to go. All right, so on this one, you should use normal CDF and treat the lower. Notice how there's no bound on the lower. We need it to be negative infinity, although most calculators don't understand that. If you have a CAS, you could type it, but if you have one of mine, it won't understand that and it'll give an error. So let's just use a tiny number. So negative 999. And then upper is 139. And you should get 0.9177. So hit pause and try and do these on your own. All right, hopefully you were able to calculate those. You should have gotten that, should have gotten that, should have gotten 0.999, 0.5, about 1.0. You should have gotten 0.5, or about 0.5, I should say. Do an approximate sign. You should get about 0 and 0.0170, 0.8599, and 0.8599. So let's talk for a moment about this third one right here. I think the calculator outputs something like this. And that's just a tiny number. That's 6 zeros and then 287. So if ever you get 4 zeros or more after the decimal, let's just say about 0. All right, I guess I should have used the approximation sign on that also. So never write 2.87. That would be bad. That'd be a bad accident because proportion should be between 0 and 1. But about 0. All right, hopefully that made sense. We're going to move on to a Tiger Woods problem. This is a real-world problem, and we're going to apply what we've been doing to z-scores and find a proportion. So read it for a minute, pause it if you need to. I'm going to start working. The first thing we grade that you have to write down on an FRQ is define the distribution. This is a normal distribution with a mean of 304 yards and a standard deviation of 8 yards. So those are points right there on your test. By the way, if this was multiple choice, you could skip that and just go all calculator if you wanted to, if you know how to do that with no work. The next thing that I count is you got to write the question in proportion notation, like that. And then from there, since we stated it's normal, now you're allowed to use normal CDF. So we need a z-score. We convert 297 to a z-score. And I realize you could do this outright by changing the mean in the calculator and the standard deviation, but they want to see work. So please show all these steps on an FRQ. We get negative 0.875. So that just translated this question to this question. And now you can jump to normal CDF and get 1908. Or it does ask percent, so I guess maybe we should write it like this. But to be honest, that's pretty picky. It's obvious you know how to work it, you would get full credit. So what I'm grading on an FRQ is I want to see the answer, I want to see the z-score, the question, and the distribution. All right, we can go a little faster now. So next one, we want the proportion of drives at least 290. Whether you write or equals doesn't matter. Has no effect on the value of the answer. So if you want, if it makes you feel better, you can put an or equals under there. But it doesn't matter because it's a measurement. It's continuous. The difference is insignificant. So let's get the z-score. And we get negative 1.75. The new proportion question we're finding is this, and the answer is 95.99. This one I'm grading one less thing because you already defined the distribution. So just those three things. All right, this one's a little bit more involved. It's like twice the work, but the same process. We want to find 305 to 325. So find both of those z-scores. So I got 0.125. And I got 2.625. And jump to the normal CDF. And you have this one. Notice I didn't even talk about lower and upper bound. So, you know, up on the part A, lower bound was negative 999. On B, upper bound was positive 999. On C, I hope it's very obvious. That's our low, that's our upper, and we get 0.4459. All right, almost done. Two more parts, but part E is a little tricky. So part D is actually very easy. Anytime they ask an equality question, the answer is 0. Because once again, this is continuous data, a measurement. We need an interval. This has no width to it, so it has no area. So proportion is area under the curve. If it has no area, it's 0. Yes, we could calculate this if we wanted, but we don't have to. That's not what they asked. So it's 0. All right, we have a backwards problem. Normal CDF, let me write this down for you. Normal CDF gives you a proportion for an answer. I already have a proportion on part E. So I need to work backwards from what I've been doing. There's a function right below normal CDF called inverse normal. This gives a value or a z-score. I'm going to write z-score because I'd rather you do the algebra needed. So the one catch to inverse normal is it asks for the area that we're referring to, and I wish they had typed the word percentile. So when they say top 10%, we're referring to the 90th percentile. So on your calculator, go to normal CDF and look right below it. You should have inverse normal. For area, type 0.9, leave mu as 0, sigma as 1, and it should give you a z-score of 1.2816. Then plug that into your z formula, and we need to solve for x. We know this side. We don't know x. We know mu. We do know sigma is 8. So really all you have to do at that point is go all calculator if you know how to do that. That's all I'm going to grade, that you wrote that equation. Let's solve it though. Times 8 times 8. Then I'm going to add 304, and I get 314.2528. So let's say it in a sentence. 314.2528 yards and greater represents the top 10%. All right, hope that made sense. See you in class.